Hi, welcome to part 2 of vectors. Today we're going to look at vectors relating to movement and position. Once again I have Bob here to help me. I also today have his friend Cedric. Okay, so if we look at something called the position vector, that is denoted by the letter R underlined because it's a vector, and the position vector is the position of something relative to the origin, O. Bob's position vector here is 5i plus 4j. Cedric's position vector, to show that that's the position vector of a vector B, we would put a little b there. Cedric's position vector, RC, is minus 3i minus 2j. Now, if we find the magnitude, and we saw in part 1 how to find the magnitude of a vector, the magnitude of a vector, of a position vector, is actually the distance. That makes sense if you think about it like this, that we have 5 along here, 4 along here. The magnitude will be this distance here, this side here, the hypotenuse, and we would get that by simply doing the square root of 4 squared plus 5 squared. Similarly, for Cedric, we would find the magnitude of his position vector to get distance from the origin by doing the square root of 3 squared plus 2 squared. Please note we don't have the negatives in now, as it's impossible to get negative distance. The answer to that will be positive. Okay, so let's look at the velocity vector now. So if we look at the velocity vector v, the velocity vector v is the change in displacement divided by time. So if we look at this example, we have Bob on his lovely green scooter. Bob is going to travel along here to end up at this position vector. He's going to do it at a steady velocity, and let's say he will take 2 seconds. The position vector he ends up at, so his position vector is 8i plus 4j. His velocity vector will simply be his position vector divided by the time it takes. So let's say it took him 2 seconds, we would simply divide that by 2. His velocity vector would be 4i plus 2j. Now, similar to what we saw earlier, that the magnitude of a position vector gives us the displacement or distance from the origin, the magnitude of the velocity vector gives us the speed. So if we were to find Bob's speed, we would simply find the magnitude of his velocity vector by doing the square root of 4 squared plus 2 squared. Okay, final part now, and we have Bob's friend Cedric on his other scooter to help us. Acceleration, the acceleration vector is change in velocity divided by time. Now in this example here, if Cedric has velocity 4i plus 3j, and that changes to a velocity of 8i minus 2j over a period of 2 seconds, what is his acceleration? I need to say we're making the assumption here that he has constant acceleration throughout this motion. Okay, it's a very important point to make. Has constant acceleration. So we're looking at the change in velocity, and we're going from, we end up with 8i, we start with 4i, so the change there is 4i. We end up with minus 2j, we start with 3j, so the change there is minus 5j. So Cedric's acceleration vector is 4i minus 5j. We can also find the magnitude of his acceleration by using Pythagoras again and just finding the square root of 4 squared plus 5 squared. Okay, that's all from me at the moment. Thank you as always to Bob and to his friend Cedric today for their help. Bye.